what is heat transfer? So just now I used a very rough example, okay? So there's somebody say that there is no such thing as darkness. Darkness is not a thing, okay? But only of absence of light. So when there's no light, a place becomes dark, okay? So you cannot create darkness, but you can remove light from a place to so-called create the darkness, okay? So to produce darkness, we remove light. So if you use the same idea onto coldness and heat, okay, so there's no such thing as coldness, okay? It's actually absence of heat, okay? So to produce coldness, instead of thinking of how to cool down this place, you might want to change your thinking, okay? Change to how to remove heat from that place, okay? How to remove the heat load inside a room, how to remove the heat load in a building, okay? So you have to, instead of produce coldness to the building, is remove heat from the building, okay? That's the concept of heat transfer. So like I mentioned just now, if you have a piece of ice, okay, that is 0 degrees Celsius, you place on a table, okay? Let's say you have a 0 degrees Celsius piece of ice, okay? You place on a table. So what will happen, okay, if the surrounding is 30 degrees Celsius, okay? Sooner or later your ice will start to melt, okay? Simply because the piece of ice gain heat, okay? Heat from the surrounding will enter the ice and heat it up, okay? And break the bonds, and after that it become liquid. If this piece of ice is placed in another environment, instead of 30 degrees Celsius, you place it in a freezer, negative 10 degrees Celsius. So what will happen? How will heat transfer take place? It will be from the ice to the surrounding. So instead of from the surrounding to the ice, now because the surrounding is a lower temperature, it's colder, so it will be transferred from the ice to the surrounding. So what I'm trying to say here is, don't look at temperature as an absolute value. Okay, 0 degrees Celsius, you can call it very cold. Okay, but in a freezer kind of environment, it's actually a hot object. So always take note of this when we talk about heat transfer. Okay, a single temperature will not tell you much. You need to compare two different values, two temperature, then you will know how will the heat flow. Okay. So now back to buildings, okay, back to air conditioning. So how do we create a room with a temperature of 24 degrees Celsius, which is the most so-called the comfortable temperature, when outside temperature is 30 degrees Celsius? So in order to do that with the concept of heat transfer, we know that you must start to remove heat from the room, okay? How to remove heat from the room? You need to put some cold object into the room to absorb the heat. So what is that cold object? So actually a big piece of ice, okay, if you have a large piece of ice cube, you put inside the room, it can do the job. Okay, you just use a fan to blow across the ice, okay, the ice will start to absorb the heat and your room will be cooled down. Okay, that can do the job, but it's not, of course, efficient, okay, because once the ice gain heat, you need to quickly remove it and replace it with another piece of ice, correct? So a simple way, okay, a simpler way is to use a cold fluid, okay, or a fluid that is cold enough. It flows inside the room, okay, and you use a fan to blow across the cold fluid, and you will start to absorb the heat, okay. When you absorb the heat, the fluid will gain heat, okay. Your fluid will gain all the heat from the surrounding, and it will flow out, okay. So instead of replacing the ice, okay, whenever it melts, you use a liquid, okay. You use a fluid that can flow in, absorb heat, and flow out. So that is a more feasible way, and that is actually the how we get cold air, okay. How we cool down a room at home or in a building, okay. So an artificial hot and cold region, because as we know, if a room is 24 degrees Celsius and outside is 30 degrees Celsius, sooner or later the room will get heated up to the same temperature as outside. That's natural. But if you want to make the room always colder than outside, then you need to create this artificial hot and cold region by using this cooling coil, okay, the cooling coil. And if you notice, cooling coil is always in a fin-like shape, Okay, so you see a lot of metal plates. Okay, so these metal plates are what we call fins. So why are fins being used in this case? Because fins, right, it will actually increase the surface area. So when there's a larger surface area, heat transfer can take place faster. Okay, compared to one single piece of metal, heat transfer may not be able to take place fast enough to cool down your air. That's why you need to have fins-like metal sheets, okay, in between, such that heat transfer can take place very fast. So if you look behind your refrigerator before, okay, you may notice that it may look something like this. Okay, it's also made out of coils and fins. Okay, so as I mentioned, the purpose is to increase the surface area such that you can reject heat faster. Okay, and usually you will notice, okay, inside your fridge is the cold region. Okay, it's a cold region. But behind the fridge is usually hotter than normal. Okay, it's not normal room temperature, but it's in fact hotter than normal. That's why you will blow out hot air. Okay, if you notice the behind of your fridge is always hotter. Because whenever you create coldness in one place, the heat must go somewhere. It is not free. Okay, you cannot just absorb the heat and that's it. It must go somewhere, and in this case, the outside of your fridge, okay, the back of your fridge, is the one that where heat is being removed. Same as your air conditioning system, okay, you will notice that you will always see this evaporator, okay, evaporator in your room, okay, but it will not work, okay. You cannot go to a shop and say, I only want to buy this evaporator, okay, this piece of device, but I don't want to buy the condensing unit. Okay, it's useless because this evaporator is in fact just a piece of fan, okay, it's just a fan with cooling coil inside, okay. But what is actually providing the cold fluid that flow into your evaporator is this condensing unit, okay, with the most of the devices is inside. So evaporator is the cold region that you put into your room, okay, whereas condensing unit, if you notice lah, is always blowing out hot air because it's rejecting the heat that it absorbs from your room, okay, from your bedroom, for example. So this condensing unit, usually where do we put it? Is that there's an aircon latch where you put this condensing unit over there, okay, where it will blow out the hot air to the environment, okay. So it should always be pointed outwards, okay. There should be enough ventilation to cool down this unit, okay. And what is actually inside this condensing unit? There's a giant fan, okay, to remove heat from the condensing coil. Okay, later I'll go into detail what is this condensing and evaporating portion. And there's a compressor, okay, which is a very, very important component of an air conditioning system. So what are some of the components that need to produce coolness, be it a fridge or air conditioning system? First, the most important one is compressor. It is a device, okay, to create a region of high and low pressure. So as the name suggests, compressor, it means you need to compress something, okay? Compress and make it into a high pressure gas, okay? And so the inlet will be low pressure, the outlet will be high pressure. So that is and usually we use this symbol, okay, this symbol to represent a compressor. So let's say a fluid flowing from this point and come out from this point. Here will be the low pressure region. Okay. Similarly, here will be the high pressure region. So you can imagine the compressor is just like an engine, okay, that will turn, okay, and compress the air until it's a high pressure. How about evaporator and condenser? Just now I mentioned a few times these two terms. Evaporator is for heat absorption. Okay, for example, the box, okay, the box that's inside your room that throw out cold air is actually an evaporator that absorbs heat from your room. Okay, and as for condenser, okay, is for heat rejection. Okay, once it absorbs heat from your room, it must throw it out somewhere, and that will happen at your condenser side. So take note that evaporator and condenser is actually just a heat exchanger. So heat transfer will take place there because there's a cold region, hot region, okay, heat transfer will take place, then the fluid will start to flow, okay, and go to condenser again, there's a hot and cold, two different fluid, different temperature, heat transfer will take place again. So they do not really consume any electrical power except the fan, okay, the fan that is being used to facilitate, to enhance the heat transfer.